Hello, Global Math student on YouTube. This is Benny Low again. In this video clip, I'd like to discuss some special cases of y equal to mx plus b. I'm pretty sure that most of you have studied this form in junior high, high school, or junior colleges. As you may recall, this is called the slope-intercept form. M stands for slope. What does slope mean? Slope means steepness, like rise over 1. And then B means y-intercept. Let me illustrate by a simple example. I have a simple linear equation, y equal to 2x plus 1. And I have a coordinate system here. It's just a simple sketch, nothing fancy. Let me try to sketch it for you. I emphasize this is only a sketch, but it will do, it will be sufficient to demonstrate what's it mean by the y-intercept and the slope. So first, you have 1 as a y-intercept, and then you simply, on the y-axis, you mark 1, like here, right here, 1. Each piece here is 1 unit, like this is 1, 2, 3 on the y-axis, and go down is -1, -2, and so on. And on the horizontal axis, you have +1, +2, +3, and so on. On the left is -1, -2, -3, and so on. And the slope here is 2, or 2 over 1. Remember, the definition of the slope is change in y divided by change in x, or rise over 1. Let me write it down for you. Rise over 1. So 2 over 1. So from this y-intercept, you simply move up 2 units, 1, 2 here, move to right by 1 unit. So you mark this point. And 2 over 1 the same as -2 over -1. So you may go down from the y-intercept 1 here, you may go down 2 unit, 1 unit, 2 unit, and move to the left by 1. So now you have 3 points. You may keep going just to have a few more points, but 3 points are sufficient. So you simply connect all the dots. If you connect all the dots, like what I'm doing here, you have a rough sketch. And then you have a straight line. You may label y equal to 2x plus 1. So this is a simple example. That's a typical case. But I want to discuss the special cases because a lot of textbooks and a lot of YouTube videos I have seen so far, they don't get into this topic. They don't talk enough about special cases. So I want to do a video to help you out. So for example, y equal to 2. That's a special case. That means from this equation, y equal to mx plus b, you just have 2, right? The slope is 0. So you have 0x plus 2, or just 2. That means the slope is 2. What do you mean by that? Let's sketch it. So do the coordinate system as a rough sketch. So you have 1, 2, 3. Y equal to 2. As you can see, the slope is 0. That means it's flat. So you simply draw a horizontal line. Like this is 2 here on the y-axis. You simply draw a horizontal line. You have y equal to 2. Okay? And then next, you have y equal to -2. In this case, it's also flat. If you sketch it as a special case, because -2, the y-intercept is -2, so you mark this point on the negative points of the vertical axis. So -1, -2 here, you have a horizontal line. Then you have y equal to -2. So this is another special case. Next, I'd like to talk about a different special case, x equal to 3. What do you mean by that? This is really special. So let me sketch it for you. I draw the coordinate system. I label the axis, the horizontal axis. This is 1, 2, 3, 4. The equation says that x is equal to 3. That means x is always 3. Okay, listen to my emphasis. X is always 3. So that means mark this point, and because x is always 3, it's kind of fixed. So you have a vertical line. Check it. X is always 3. There's no y-intercept. Alright? So this is a vertical line, and it has an infinite slope. That means the slope is undefined. A typical analogy is, imagine the space shuttle. The space shuttle, this is the ground level. If the space shuttle is trying to get launched all the way into the sky, into the atmosphere, it has to overcome an infinite slope. a lot of energy. That's why you see a lot of exhaust, from the bottom of the space shuttle. As another example, x is equal to -3. So how do you sketch it? I draw the coordinate system, label the axis. This is the origin. So big -3, I concentrate on the left hand side, -1, -2, -3, -4. You mark -3, x is always -3. So you have a line now. X is always -3. So you may contrast the two examples. Your x equals 3, you have the line on the right hand side of the plane, and x equals -3, you have the line on the left hand side. So this is another special case. Now what about x equals 0? This is also very, very special. Let's investigate this. Draw the coordinate system. Y-axis, vertical axis. X is a horizontal axis. What's it mean by x is always 0? Remember earlier, when x equals 3, you have a line like here, fixed on the point x is 3. But now x is always 0. So if this axis, x is equal to 0, let me label it. Whenever you see x equals 0, it indicates that that's the equation of the vertical axis, of the y-axis. One more case. How about y equals 0? How do you interpret this? So draw a coordinate plane, or the Cartesian plane. This is 0 here. And you may label the y-axis at 1, 2, 3, and the -1, -2, and so on. What's it mean by y is always equal to 0? As we discussed before, the slope here is 0. That means flat. So y is always 0 means the horizontal axis. Y equals 0. As I said, it's too bad that a lot of textbooks in this country do not discuss these special cases in detail. So that's why I want to draw your attention to some of these special cases, including both the vertical and the horizontal axis. And I hope these help. With these videos I'm producing on YouTube, and also some of the videos that might accompany your textbook, I hope you will be able to master these topics, especially y equal to mx plus b, the slope-intercept form, and some of these special cases. So long for now.